Assalamu alaikum. Hello everyone. Today we will be solving this Mole's question. It's from the International A-Level Edexcel Chemistry WCH 11 Unit 1. Okay, so let's get started, guys. Okay, the element iron forms two chlorides, iron 2 chloride and iron 3 chloride. Okay, iron powder is added to 200 centimeter cube of iron 3 chloride and the concentration is given, and at the end of the reaction the solution only contains iron 2 chloride. Okay, we have here the initial mass and the final mass of the iron powder. Part I, calculate the number of moles of iron that react. Okay, so guys, you know that the moles for solid equal mass over mr, which is equal to the mass is the difference between the initial and the final mass, so 6.17 minus 3.38 over the mr of iron, which is 55.8. This is equals to 0.05 moles. Okay, double I, calculate the number of moles of iron 3 chloride that react. Okay guys, so the moles for a solution equals to concentration into volume. The concentration was given in the question, which is 0.5 into the volume. It's actually 200 centimeter cube, but remember guys, you need to convert it to decimeter cube, so you either divide by 1000 or multiply by 10 to the power minus 3. Do the math using your calculator. You will get an answer of 0.1 mole. Okay, part triple I, use your answers to AI and AII to write the ionic equations for the reaction. The ionic equation for the reaction of iron with iron 3 chloride include state symbols. You must show your working. Okay guys, so iron, actually we have solid piece of iron. It reacted with iron 3 chloride, which is an aqueous solution. This was stated in the question. At the end we have an aqueous solution of FeCl2. Okay, it's also an aqueous solution. So guys, the ratio between the moles of iron and iron 3 chloride is 0.05 to 0.1. If we simplify this ratio by dividing everything by 0.05, we will get our answer as, we will get the ratio, sorry, as 1 to 2. Okay guys, so we know in ionic equations solid stays the same, so we have Fe solid plus the chloride ions will be cancelled. Okay, we have Fe positive 3 as aqueous, and at the end of the reaction we'll have Fe positive 2 as aqueous also. Okay, and for the ratio guys, here we have 1 and here we have 2. To make the balance, you just need to add 3 here. Okay, the ratio of 1 to 2 we got it from the moles, guys, from the moles ratio. Okay, part B, the concentration of the solution obtained in A is increased by heating it gently to remove some of the water. The solution is allowed to cool and pale green crystals of hydrated iron 2 chloride FeCl2.xH2O forms. Okay, analysis shows that these crystals contain 28.1% by mass of iron. Calculate the number of moles of water of crystallization X per mole. Okay guys, so we know that we have FeCl2.xH2O. okay guys, and we need to find X. So guys, we have an important information that was given in the question, which is that this one contains 28.1% by mass of iron. What does this mean, guys? This means that 28.1 equal mr of iron over total mr, I mean the total mr of this, guys, the hydrated iron chloride, times 100%, times 100. So we can easily find the total mr, guys. So let's call this y. Okay, so 28.1 equal 55.8 over y times 100. Just go, guys, using your calculator and do the math, and you will get y as y equal to 198.57. So guys, remember that this is the total mr. Okay, we need to find X. So what we can do is just subtract the mr of FeCl2 from it, which is equal to 198.57 minus the mr of iron chloride, guys, is actually 35.5 times 2 plus 55.8 is 126.8. So if we subtract them, we will get our answer as 198.57 minus 126.8 equals 71 71.77. Okay, 71.77 guys is equal to mr of xH2O guys. Okay, of the whole water. Okay, so we need to find x. What we can do is divide this one by the mr of 1 mole of water. We know that H2O has an mr value of 18. So what we can do to find x is just do 71.77 over 18. 71.77 over 18. So x equal to 4. 3.98. So which is approximately equals to 4. So x equal 4. Okay guys, hope everything in this question was clear, and if you have any questions, please let me know in the comment section. Thank you.